Hey guys, Mark here at Blue Glow Electronics. A simple little project today. I've got a new set of horn drivers that I'm wanting to try out, and that'll be a separate video. But today, I had some compression drivers that I had found at a Hamfest a few years ago, and I thought, I want to see if these are usable, what kind of shape they're in, and then I want to actually, as long as the voice coils and the diaphragms are good, then we're actually going to use these things. So let's go through the steps that we would do to figure all that out. So we'll just focus on one driver instead of on all three of them, but we'll repeat the process for all of them. First and foremost, these little screws were down in the case, and all the back case here is just to cover the back of the diaphragm and the wires connecting inside. And I had to break off the, believe it or not, 60-year-old JBL emplaced plastic covering for these screws. I hated to do that, but I want to get these out and see what kind of shape they're in. So just as simple as 2 Phillips screws, take those out. Sometimes these caps are a little tough and you have to kind of work from one side and pop them. Sometimes you hit them a little bit, but eventually they'll break loose. It's just many years of, you can see around here the edges where these things have kind of started to corrode together a little bit. But then on the inside, good news is, looks like I've got a complete voice coil here, but the bad news is, or complete diaphragm, it's not got holes in it. We'll get to the voice coil next. But as you can see, there's tons of debris down on the voice coil, and you're like, well, what's that from? Well, this foam right here, you just touch it and it just disintegrates. As a matter of fact, this was how it was when I took the back off. All the stuff was down on this and it just went everywhere when I removed the back. So we want to be able to get to the foam. So what we're going to do then is we need to get the binding post off here first and get loose. And take pictures along the way, guys, so you can just put things right back the way they were, so that you'll know the red wire goes on the left here. And we'll get that one loose. And then this one loose. And if you'll notice, there's a rubber grommet on the back here of each of these. You've got the wire coming down going to a terminal lug. Then you've got a rubber grommet here on the back of this. And sometimes you'll have to use an actual screwdriver to unscrew from these rubber grommets. By the way, these things are super hard instead of being soft and rubbery like they should be. But then on the other side of this, you'll also have a rubber grommet here. And fortunately on these, those came off with the terminal lug here. And I'm actually going to replace the binding post at the same time. And I'll use just a toothbrush to get in here and clean up this area really well. Up next, I'm going to take this off to the side and use a air compressor and just a super lightweight paintbrush to clean out in and around here and get all this foam debris off of this. Right, up next, just using a typical ohm meter, I'm measuring the DC resistance of this voice coil. Keep in mind that has nothing to do with the AC impedance that you would see, but we're at 10.8, and I just like to write that on here so I kind of know what it is. But the good news is it's not shorted and it's not open, right? So if it was open, it would be, you'd see no connectivity here, and shorted, this would be, 1 ohm or less or so. But so 10.8 ohms on this. Okay, now that we've got the back, we've got the top off, and I take it away and I clean this around, make sure all the debris was gone. Next thing I want to do is take the voice coil off itself. By the way, these wires, guys, notorious for coming loose because they're just crimped. I always like to take a little solder here and solder them on. Some people actually like to replace the wires, but anyway, the 4 wires here tied to, or the 4 screws here tied to the wires, right? The ones that go down to the voice coil or through the diaphragm to the voice coil, and the ones that hold these wires on. They don't have anything to do with holding the diaphragm to the actual magnet housing here. So there's just 3 screws really that you need to remove. And then you can take off the voice coil. And typically they come out fairly easy. This is how you would go about replace them. I like to put 4 fingers here and I kind of use them and leverage them like that and lift upwards straight up at the same time. Oh boy, that doesn't look good. we've got a good bit of corrosion here, as you can see on this the magnet housing itself. But you know, the voice coil doesn't look bad at all, except for right there. You see all the corrosion in that? We may be able to clean that up and this turn out okay. What this tells you is that you know, moisture has gotten down through the horn into this part, you know, of the housing. And you know, next we're going to clean the voice coil, but first I want to get rid of this gunk. So after a little further inspection here, I'm pretty confident that we can actually clean this part up. What we don't have is a lot of corrosion that's bridged the voice coil gap here. There seems to be some on the outside, but it doesn't look like it's rusted down in there, anything down in the voice coil that's killing it. And you can use just like a piece of cardboard stock here to run around and determine there's no super rough spots or whatnot. So I think I'll be able to clean this off with a brass brush really good, and then we're going to have to clean out this voice coil gap really good. But the bigger item in question now is this, and I'll show you what we're going to do about that. All right, as you can see, we got it all cleaned up with just a brass brush here. And you know, some people say to use brake cleaner to clean these out. I actually used some Deoxit D5 because I knew we were dealing with some oxidation here. But the key, whatever you do, you've got to get it dried out. So once I cleaned it out real good and I held it upside down and I sprayed in here really good, then I used an air compressor to blow out inside real good all the way around to make sure I'm getting all the debris out of there. And I need it good and dry down in there. But then you got to follow that up with actually cleaning out the voice coil here, or the voice coil gap. So I always start that out with something like a business card, just some card stock. And you want to go around and make sure there's nothing big in there that would kind of be in the way. And you can see here I'm getting a little bit of dirt around the edge of this on both sides there. So I'll do that a few times. And then, so once you've cleaned this out well with some cardstock all the way around quite a few times, and you've vacuumed it out, you've blown it out, whatever, you're gonna need to get some tape down in here. And guys, you'll just have to work with the tape. The larger the voice coil gap, the easier this is, but on really small stuff like this, I end up with just some blue painter's tape down in here, and you need to work it down into the groove and then kind of move it around as much as you can. And you need to do it both directions. So I'm kind of moving it this way, and then I'll have to use another piece of tape to get the other half. But you can see I picked up some stuff there. And then you'll need to get a piece of tape and turn it and go the other way. So you're getting the outer part here both directions all the way around. And you just want to keep doing this till you no longer get anything on your tape that you're using. Some people use clear tape. Some people are using just plain old, like me, I'm using some blue painter's tape, whatnot. But that's the goal, is to get every piece of debris out of there as much as you can. Okay, we got that finished. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pieces of tape I ended up using to get that cleaned out well. And I went through several pieces of cardstock here in the process as well. But at this point, I can take this voice coil gap over underneath the microscope and look down in there all the way around as well. All right, and this little area right here is the voice coil gap. And you just want to go around and look and make sure, and what you're seeing there is metal on the bottom, just the roughness of it. But there's no debris down in there is really what I'm looking for at this point in time. And I've gone all the way around and I'm not seeing anything. These little microscopes are really handy in the electronics work. So what I'm really trying to figure out here on the voice coil, and I've got it up on a little electronic magnifying thing. See all this white powdery stuff, which by the way is just corrosion that was coming off the aluminum. And what I'm trying to figure out here is, does any of this penetrate through the enamel and get down into the copper wiring underneath of it here? And I don't think it does. So I'm going to try cleaning it off. Look, I would love to use some deoxit or something of that nature on this. The problem is I'm afraid over time it could play into either you know, the bonding here on the paper, anything holding it together, or potentially the enamel on these fine wires. So I'm going to try to do it with maybe a Q-tip and some white vinegar that would help neutralize this corrosion. All right, and you can see here I'm just going around. I'm using a little, it looks little, it's a monster on this thing. But you can see here the Q-tip with a little bit of white vinegar on it. All that white is gone now. And it's looking really good. I'm rolling this thing all the way around, guys. And as you can see here, I've just been soldering the little terminal lugs to the wires here on both ends so that we don't have any crimp issues. Okay, up next what I'm doing is I'm hooking a function generator up to this diaphragm here, to the speaker connections. And I want to make sure that whatever frequency you've got your function generator, audio generator set on, is somewhere north of 1000 hertz when you start out. So I've got mine set to 3000 hertz right now. I'm going to turn this on. I've got the volume or the amplitude as low as it'll go here, but you'll notice as I turn it up, it sounds quite loud there. And as I turn and just kind of scan, that's around 1000 hertz right in there. And I'm not sure if you guys can hear this or not. That's about 6,000, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. By the way, I stopped hearing it around 13.8 myself. That seems to be the end of my hearing range. But what I know is the driver's working, and I'm not hearing a lot of rough, harsh sounds to it. So I feel like we got the voice coil cleaned up really well, and I feel like the gap that we've got is cleaned out really well. So based on that, we're going to start putting this back together. One more quick word of caution on what I just did. Please make sure you don't drive these with a lot of voltage, especially unloaded on the front side here. We'll test some more with a speaker here in a minute, or an amplifier here in a minute, and hear some real sound. But what you don't want to do is send any frequencies below about 1000 to 800 hertz range to this thing. You can really do some damage to the voice coil. What you don't want to do is hook this straight up just like a speaker and play music into it, and you're getting the whole frequency spectrum. These things are really designed only to pick up the high end of the spectrum, and that little voice coil can't dissipate the heat of the lower frequencies that would be required, because it really can't play them well, so that turns into heat, and next thing you know, your voice coil's gone. Okay, next from Simply Speakers, I got a set of binding posts to replace these old ones. The springs on these things just kind of give out over time, and these were really cheaply made. Looks like it didn't come with new rubber gaskets, so it looks like I'm going to have to reuse these or find some just little rubber washers to replace them with. A little tip, once you get all the foam out of it, you still got the sticker that was part of the original kind of foam stick-in thing. And if you try to scrape this thing out, you will spend forever. Well, what I found is you can kind of use your finger here and just roll this stuff, and it will slowly, as you can kind of see here, it's a little bit tedious, but you can start to really kind of just roll this stuff off here like I'm doing right now. When you get done, there'll still be little pieces that you can't get off. I love this stuff right here. It's called Rapid Remover, Adhesive Remover. It's the best, you know, we've all used like gunk and whatnot in the past. But this stuff right here is super. I learned how to use this from guys that remove great big stickers, emblems, whatnot, off of video arcade games. And so you're talking some great big stickers that take a lot of time to get off, and this is the stuff they use. I'll put a link to all this stuff down below. And there we go, all ready for my new felt. All right, I found these felt pads on eBay. A guy makes them and cuts them out, and apparently I ordered the wrong size units. So anyway, I'm gonna have to get out some scissors myself and get to cutting here and get this down to the right size. But I did reach out to a few friends of mine about what to use in the backs of these, because what I don't want to do is end up in this foam place again down the road. And you can find open foam sale. It's the kind of stuff you use around doors and windows for weatherproofing and whatnot. But much more recommended was some loose fiber felt, if you can find it, that's got some thickness to it. Looks like this is nearly a 1/4 inch thick here, and we just need to trace it out and put it in there. So yeah, I ordered the wrong size, apparently. Okay, my round circle cutting skills are not as good as the guy that sells these on eBay, but you get the idea. I've got them in here, and they're actually similar, actually maybe slightly larger than the original foam. And it looks like maybe they had, the way he made these, they had been designed to cut out for these notches, but I just went with the inner circle, and I actually just used the center of this tape to draw a pattern here. It turned out to be just perfect. But it's not perfect, but it's good enough. All right, when putting the binding post on, you want to make sure, one, you're kind of coming from the side here and not straight in it or across from the other side with the terminal lug on the back. And two, you want to make sure that this little hole that you stick your wire into is sticking straight outwards, so you're not off to one side or another. But once you get that tightened down, move on to the next one. It's a little bit of a juggling act to get the wires coming in from the sides, okay? Then you've got to get the binding post with both of the holes outward and make all that happen. And you want to double check and make sure that you're not shorting to the chassis with either one of these. So a good ohm meter check on that would help. All right, so we're just checking no continuity between these. That you'll have some resistance there in the voice coil. You're good there. That's the 10.8 ohms. But you want to make sure between here and here you don't have continuity between the case. See, this case is conductive even though it's aluminum. But that's the purpose of those rubber washers there. If you'll notice, there's a little metal tit right here, and this thing can only go one way. So when you fold it all back down, you got to make sure the wires don't get in the way or touch the voice, the diaphragm. And you just want to kind of line everything and get it back together and tighten it back up. All right, believe it or not, we're good. The speakers the horns I'm gonna hook these up to crossover at roughly 1000 hertz. That's what this is right here. And if I can get a good bit of volume out of this, and frequency wise, it goes up beyond what I can hear, so we're good. All right, guys, that's how we refurbished. And keep in mind, if you were replacing the diaphragm, exact same scenario would have played out here. You would have just put a new diaphragm in it instead of redoing the used one that I did. And just for reference, these are equivalent to a JBL 2460 speaker. That's the closest crossover we've been able to find, and they as well have the phenolic diaphragm inside of them. So stay tuned, guys. Got some new horns coming up we're going to play around with, and these are going to be the drivers we use on them. I feel like we're good to go with this one, and it was the worst of the three out of the bunch. Hey guys, just in the event anyone's interested in this little microscope, if not, you can drop off, and that was the end of the video. Thanks for watching, everybody. Otherwise, a little bit of an infomercial on these. I originally bought this microscope when I was doing this was part of my day job. We were needing to replace some batteries and some telecom equipment. And we were trying to reverse engineer this charging board here, because these batteries are just super easy to obtain. But the charging board's a whole nother story. So we were in the process of reverse engineering this board, and I needed this camera to be able to read some stuff here. So I picked this up. Great little unit, and You know, it's got built-in lights you can turn on here. It's LED light driven downwards. Just great zoom, and I'll post a link down below with the specs. But this thing's 79 bucks. I mean, I've gotten the heck of a lot of use out of it for the money that's in it. And this is the 7-inch screen version. They also have a 10-inch screen version. But anyway, that's enough for an infomercial today. Thanks for watching, everybody, and we'll keep doing stuff down here in the audio barn and bringing it to you. Thanks, everyone.